Okay, so before we look at the notes, we have to look at this, right? We have to kind of talk about number systems because we have to use this in our notation. And so we have real numbers, rational numbers, integers, whole numbers, natural numbers. These are all things that you learned like forever ago. So if you're counting numbers, then if you add 0, that becomes the whole numbers. Then positive and negative becomes your integers. These also have letters that correspond to them, which to me, these two make sense. These two don't really, but I don't know why they are what they are. They just are. But my projector isn't that good, so you probably can't tell how it's really written. The letters are doubled. So like the Q actually looks like that, and the Z actually looks more like that. It's like a double thing. So it's not just a capital letter. But we're going to use integers in our notation today, so we're going to be using this weird Z. I just want to make sure that you know that that means integers, because we're not actually writing it out. Okay. All right, so this is going on page 99. This is just your unit circle again. Okay. All of your radians, all of the ordered pairs. Since this is a unit circle, these x values are cosine, the y values are sine, because it's a unit circle and only on the unit circle. When we move into the function part of this, that changes, okay? So when we look at sine first, our parent function for sine, f of x equals sine of x. So our input is x, which is going to be an angle measure. Our output is the sine of that angle. So these parent functions, we're going to get our anchor points on here, which is a very simple thing to do. And when you graph these, if you follow the patterns I tell you to follow, these are a piece of cake. Okay? If you just decide you want to do it on your own and not pay attention, it's going to be very difficult. All right, so the first thing, what is the sign of 0? 0, okay? So here, 0, 0 is a point. We just talked about the fact that the period for a sine function is 2 pi. So if I start here, I'm going to go like this, and then I'm going to end at 2 pi before I start over, so that has to be 0, right? Plus 0 and 2 pi have the same sign value, right? What is the sign of pi? 0. Sign of pi is 0. So notice here, I get the beginning and the end of the period, and then halfway in between, it's also 0. And because I know the shape here, halfway between 0 and pi is going to be my maximum, which is at what? 1. And then halfway between pi and 2 pi, that's 3 pi halves, I'm at negative 1. And then the same thing happens for the negative. I still have a period of 2 pi, so I can put a 0 there. Halfway in between is another 0. And then at negative pi halves, I'm at negative 1. And at negative 3 pi halves, I'm at positive 1. And then I can get that curve drawn in. And put arrows at the end. Okay, on the fettuccines we just did, we stopped because we had a restricted domain, but put arrows on the end so you know it's just going to keep repeating itself. Okay, we good? We could plot other points because we know what the sign of pi fourths is. And we know what the sign of pi thirds and pi sixths is, but those are decimals, and we'd estimate, and it wouldn't look much different than it does right now. Might actually make it look worse. But that gets us the general shape and idea. Okay, we all good so far? So our domain of the parent function, what's the actual domain? Negative infinity to infinity, right? What's the range? Negative 1 to 1. Okay. Zeros. All right, well, how many zeros do I have? An infinite amount, because it keeps going, right? So this graph's going to keep going, and it's going to intersect that axis an infinite amount of times. Make sense? All right, so I have to have some way. I can't put infinite here because this doesn't ask me how many. It asks me what are they. So I have one at 0, but then how often do they happen? Every pi. So it happens every pi, right? And so my zeros, I can say that it's actually n times pi. But then I have to clarify because n can't be 1/2 because it doesn't happen at pi halves. So n pi, where n is an element. So this looks like a weird C with like a line through it. That means element. So it's like I'm going to do that with that's what element is. N is an element or a member of the integers. And integers is that double Z thing. Okay. So that takes care of positive and negative, because integers are positive and negative. So n could be a -3, it could be a +2, it could be 0, right? Because we have one at 0, one at pi, 2 pi, 3 pi. Okay, does that make sense? That's what the notation looks like for that. All right. So what is our y-intercept? 0, 0. Do we have any asymptotes? Nope. Okay, and then the amplitude. So the amplitude is something we'll talk a little bit more about tomorrow, but it is the distance on the parent function from the x-axis to the maximum. So your amplitude right here is just 1. That's gonna come into play when we start stretching the graphs and have our transformations. And what did we say the period is? 2 pi. Okay, so one of the things when I ask you trig values, like one of the hardest questions I seem to ask you are for the quadrantals. Like it hurts your brain to think through that for some reason, and you can rattle off the other ones. But I feel like understanding these graphs can really help you with that. When I ask you what is the sign of 0, and if you don't just know, instead of picturing the unit circle and well that's at 1, 0, and then that's the y value, if you picture this graph, well it's 0, 0, because you know where sign starts, right? You don't even have to think about it anymore. Okay, the sign of 0 is 0, which means that's what 2 pi has to be and what pi has to be. And you can get your values from that as well pretty easily. Okay, we're going to leave this part blank right now. We're going to come back when we talk about transformations. Otherwise, it's just going to be way too much for your brains today. Okay, are we good on sign? Because we have to know how to graph these. We have to understand what's happening with them, and we're going to, like I said, transform them like crazy because we're going to be graphing for a while. So let's look at cosine. Maybe. Okay, let's look at cosine. So my parent function, f of x, equals cosine of x. And I will repeat again. Cosine is only the x value for a unit circle, and this is not a unit circle, this is a cosine graph. So our input is the angle, our output is the cosine of that angle. So what is the cosine of 0? 1. So go to 0, 1, and make a point. The period for cosine is 2 pi. So I'm here at 0, I'm going to come down like this, and then it's going to end right here at 2 pi. The period ends, the graph. So because, again, I know what the shape looks like halfway in between at pi, I'm not at 0, I'm at -1. And then halfway in between at pi halves, I'm at 0, and at 3 pi halves, I'm at 0. And then I do the same thing on the other side. -2 pi, I'm up here at 1. Negative pi is -1. And then get your zeros in there. That's why understanding those quadrantals are so important. And then you get the shape graphed in. So what's the domain? Don't forget your arrows because this keeps going. What's the domain? -infinity to infinity. Right? What's our range? -1 to 1. So our zeros, how many zeros do we have? An infinite amount. How often do they happen? Every what interval? It's still every pi. Because if you look at where this happens, if I translate this to the left, okay, so it's still, because yes, it happens at pi halves. Another pi halves would be at pi, and I don't have a 0 there. So it's still happening every pi. It just doesn't start at 0, okay? So I can't say it's n times pi because that means pi, 2 pi, 3 pi, and that's not what's happening. I have to shift it over a little bit. So I can start with, hang on. All right, there we go. So I can start with pi halves, and then to that I can add n times pi. Because as long as I start at pi halves, and then it's every pi. And that, remember, n is an element of the integers. So that means positive and negative numbers. So n could be -1, it could be -2, and so forth and so on. Okay? Okay, shh, sit. All right, so what is the y-intercept? 0, 1. Okay. Do we have any asymptotes? No. What's the amplitude? And what's the period? 2 pi. Okay. All right, so from all of that, tell me, what questions do you have? Any questions at all? Okay, so do you think you could graph these parent functions? Okay, knowing those ordered pair, I mean, you know what the values are. You should be able to plot every single one of those points. Okay, so you've got to be able to think through this and process through this, because tomorrow we're going to revisit this. We'll talk about amplitude a little bit more and some of the other features of it, but this is where I'm going to leave it today. Okay, questions? We good? Awesome.